Hello guys, how are you? I just wanted to make a short video for this specific topic. As I don't know how to make videos actually, I just decided to record a Zoom session and that's it for making this video. And yeah, I just decided to start with measures of central tendency before talking a little median about the median. So I'm gonna make this pretty quick. I'm going to speak a little about first the basic concept. I know that you understand this topic pretty well. The three different measures of central tendency are the mean, the median, and the mode. Basically, the mean is the average of your data. The median is a number that is in the middle, and the mode is the most common value. I think that is pretty clear actually. What is not commonly known, I think, is that the mode is the least affected value or yeah, the least affected value by outliers. Actually, the topic says that it is the median, but it is not. I think that is what they are referring to is that the median, that the mode is not commonly used for statistical analysis. So if we talk about statistics, we mostly use two, the median and the mean. We not use the mode very common, but the least affected one by outliers is the mode actually. Talking a little about the distribution of your data. I think you know that the distribution has to be, or um, it, well, it could be symmetrical, but that is normal. But there are some I could say like non-normal distributions of the data that, for example, we have the bimodal distribution, we have the positive skew distribution, and we have the negative. The bimodal is pretty commonly seen in, for example, in Hodgkin lymphoma. That is mostly what I've seen that curve before. For example, in non-Hodgkin lymphoma or in Hodgkin lymphoma, sorry, we have a bimodal distribution of the ages. We have a high prevalence in the young, and then high prevalence in the, I would say, people around 50 and 60s. But we have a decline in incidence and prevalence in people in between, like in the 30s, 35 or so. That is a bimodal distribution of the ages. Positive skew distribution is yeah, a negative skew distribution is when the data is transformed by outliers, or when you have outliers in your data, and that causes a non-normal distribution. For example, here you can have a high outlier that sits here and that change the composition of the curve, or you could have a negative outlier that sits here and change the curve for a negative value. And here you can see how the central tendency measures change with the lawyers, and we can see here clearly that the mean is the most affected value, and that the mode is the least affected value, and the median is in between. Here I bring an example of how a median is measured. I'm not going to take too much time here. Here you have a student that has 6 patients, and here is the values of the triglyceride of the patients. And I just wanted to make a point here of how the median is done. So if you want, you can pause the video and do it 2 minutes in your house. So if you do this exercise, you see that 92% of the people responded well. That is like pretty easy. This was taken, by the way, from a QBank of the STEPS exams that are for residency. Here you have that the response is 172.5. So how we took the number, because you can say that okay, it's the middle value, but there are some tricky points. For example, we have a tricky point here. We have that 2 patients have the same value, 175. If you have the same value for 2 patients, you have to repeat the value. You have to put those values. You don't like write only one value. That is not correct, and that is a commonly done mistake. So if you order all the values that you have in your data, you have to take the extremes off. Like you take these extremes off, and you leave with these two values, and if you take these two values between the middle, you would have that 172.5 was a response. Here you have the mean, the median, and the mode. I calculate them just to complete the exercise. But what happened if we add outlier? Let's say that we don't have 6 patients now, but now we have 7, and now we have a patient that has 280 in the value of the triglycerides. So now that all the distribution is going to change. Like in the past exercise, the distribution was somewhat symmetrical. I could say, I'm sorry if my drawing is too bad. Somewhat symmetrical. We could say that it would be completely symmetrical if the mode, the median, and the mean was the same. Actually, if the 3 M's were in this spot, you would have a perfectly symmetrical curve. But for example, in this example, this curve is going to change for change the color of this. It's going to change for a positive distributed curve, right? So this 280 is going to sit here, making a positive distributed curve. And here you would have, of course, the mode that was not changed because the mode is 175. You have the mode here, and it was not changed. Yes, you have the mean that I calculated, and it's 186. So maybe we can have the mean. This is the mode. This is the mean. Yeah, mean. And well, the median is going to be the same as the mode. Well, this is a specific example. We don't have the same median and the mode. But what commonly happens is that the mean is here, the median is like between the mode and the mean, right? So why don't we choose the mode if it is not changed by the outliers? Or then we choose a mode. It's pretty obvious. But it's not useful. It is not useful. I found what I thought about 2 reasons why, but you can add more in the posts. First of all, because if we have unique values with low frequency, let's say that we have a small sample, we don't going to have a mode. If we have all the values are different, we should not have mode. And if there is more than one mode, like that could be another problem. Like you have the exact frequency of different values. For example, you have 275 and 270. You would have like different modes there. I don't know honestly if those are dividing between them, and there you can find the mode. I think that it's not. So that is why it's not commonly used, because it is not used for discrete or continuous data, basically. So for a statistical analysis, should we use the mean or should we use the median? That is the question of the topic, actually. It depends. Actually, it depends on how your data is distributed. If it is symmetrical, you should rely on the mean. You shouldn't use the median. If your curve is symmetrical. But if you have skewed data values, you should use the median. Why? Because that is the least commonly affected value by outliers. For example, in the example that I just presented, the first sample that was not with the outlier, we should rely on the mean if we want to do a further statistical analysis. But in the second one with the 280, we should use the median for a statistical analysis. Basically, that is like the point I want to make. But okay, so suppose that we have a symmetrical distribution. Yes. Why we should rely on the mean? It was one of the questions that I had in my head. Okay, we have a symmetrical distribution, but why? Why we use the mean and not the median, for example? What I found and what I thought about is that the mean is most commonly used for statistical methods. For example, the standard deviation, that is the how much variability, I think it is written here, how much variability you have in a set of values around the mean. For acquiring a standard deviation, you should use the mean. Like the full name is standard deviation of the mean. So if you have the opportunity to use the mean and you don't have like huge outliers in your sample, or the outliers are balanced, I think that using the mean could be somewhat beneficial. And is also used for many procedures, like for example, the t-test and many others. For example, for standard error, you need the standard deviation. And if you don't have the standard deviation of the mean, I don't know how to calculate the standard error, honestly. So I think that is why the mean is most commonly used. So I just leave it here, short and sweet. I was talking in the group that we should do questions in all the posts, because the questions, like for example, this topic has 2 questions and those can be answered too quickly. And if we don't do further questions, it would be too hard to not repeat the same. So I bring 3 questions for you. Whoever wants to answer could do it. If you know a study where the median was chosen, I didn't talk about that. I think that is one of the questions of the topic, but I didn't talk about that for you to talk a little about this. If we choose a median, in that study, how can we conduct the statistical methods? Yeah. So for example, the standard deviation. Does it change to a mean absolute deviation? No, I'm sorry, this is wrong. To a median absolute deviation. So the question is, if we have a study that used median as for a statistical analysis, should we change the standard deviation to a median absolute deviation in order to conduct further testing? I don't know. Actually, I don't know. That is one of the questions that aroused me. I want to like look for answers tomorrow. So yeah, this is my video for topic, and this is my opinion about this. Hope you like it, and have a nice weekend.